Good afternoon, good evening, good morning to everyone, wherever you are tuning in from today. Thank you for joining us for this webinar hosted by the Stockholm International Peace Research Institute, SIPRI, with the title 3D Printing Missiles on Demand, Additive Manufacturing as a Challenge to the Missile Technology Control Regime, or MTCR. My name is Collier Brockman. I'm a researcher with the Dual Use and Arms Trade Control Program at SIPRI, and I will be leading you through this webinar today and moderate the discussion of the distinguished panel that we have with us here today. With that, let me now turn over to my colleague, Sibylle Bauer, for some welcoming remarks on behalf of SIPRI. Sibylle is Director of Studies, Armament and Disarmament at SIPRI, and her own background and expertise is actually also in the field of export controls. And Sibylle is also the chair of the EU Non-Proliferation and Disarmament Consortium, a network of leading think tanks working on arms control, disarmament, and non-proliferation in Europe. Sibylle, I'm very happy to have you here with us today, and the floor is yours.
Thank you very much, Collier. Yes, it's a great pleasure also from my side to welcome you all to this event on behalf of SIPRI. SIPRI has a long history of working on export controls. And as part of that, actually starting already in the 1990s, we followed very closely the developments in the export control regimes and covering that in the SIPRI yearbook. And I can say from my own experience, when I started in 2003, that it was a lot more difficult because there was a lot less information available on the regimes. They've become a lot more transparent with more information in the public domain. And this is actually also part of this effort, this particular event. Within our research efforts at SIPRI on export controls, recently we've put a particular emphasis on emerging technologies, and including looking at the role the regimes play in this context, and also what kind of efforts they've made, what kind of challenges they face in addressing emerging technologies. And this webinar is part of this research, and it's also part of a larger project that is being conducted on the future of the MTCR. And it has the nice title, Quo Vadis MTCR, the Missile Technology Control Regime at a Crossroads, taking me back to my Latin studies days. This is the first webinar. It also is based on the first paper, which was just published and you've all had access to. And it will be followed by more webinars and also more papers on other topics. There'll be one on hypersonics, one on the new space industry, and one on the future of the MTCR. And I would very much like to thank the foreign ministries of Germany and of Switzerland for their funding of this project, for their great support in the implementation of the project, and also for the very active role that they've been playing in this particular issue area. And of course, Switzerland will be taking on a special role with their coming chairmanship. So now let's focus on additive manufacturing, and in relationship to the MTCR, it actually takes me back to a paper that Collier and I co-authored 4 years ago at the occasion of the 30th anniversary of the MTCR. Some of you may remember that. So I'm very much looking forward to hearing from our panel how things have been developing since and what kind of efforts could be taken to address this specific challenge of additive manufacturing. So with that, over to you, Collier.
Thank you, Sibylle, for those opening remarks. And I would like to also give the opportunity to provide some brief remarks to Mr. Nicolas Plattner on behalf of the Swiss Federal Department of Foreign Affairs. Nicolas Plattner is head of the Arms Control, Disarmament and Non-Proliferation section and deputy head of the International Security Division at the FDFA. Thank you for joining us here today and for the continued support to our project, very much echoing Sibylle in that aspect. The floor is yours.
Well, thank you very much, Collier, and thank you very much, Sibylle, for those kind words, and thank you for the organization of the webinar and the opportunity to address you with a few words. I think it's very timely to explore the issue of additive manufacturing and its impact on missile technology control regime. And it's our priority to ensure that the MTCR stay abreast of technological developments in the field of missile. This is all the more important given the fact that there are not that many instruments regulating the proliferation of missile internationally. Next to the UNSCR 1540, we have the H Code of Conduct, whose subscribing state politically commit to prevent proliferation. As an export control regime, the MTCR needs to strive to prevent the proliferation of WMD delivery system as well, through international coordination and harmonization of export control. To achieve this goal, the regime needs the regime cannot remain static. Advancement in technologies and industries have to be evaluated constantly, continuously, and taken into account. The MTCR and its 35 partners use the annual reunions and the technical expert meeting to take stock of those development and discuss proposal on how to adapt the regime to this development. And we just concluded a successful plenary week in Sochi in Russia. We're very happy to see Andrew Horton as the MTCR, as an MTCR insider, so to say, and current chair of the technical expert group on the panel. That's very good that you participate, Andrew. And in addition, we believe that exchange with academia on issues such as this one is of primordial interest. We thank very much SIPRI for having already produced a very informative research paper on the issue, which will be the subject of this discussion. And we're of course very pleased to support you financially and SIPRI's work in general on the regime, as you nicely framed the Quo Vadis MTCR. We hope that this the outcome of the project, including this webinar, will help us gain some insight from experts in the field, and will help us also to determine where the MTCR is heading. We wish also to use this, of course, as an opportunity to best prepare for our own chairmanship of the regime from October 2022. With that said, I'm looking very much to the discussion, and thank you again, SIPRI, for organizing this webinar. Thank you. Back to you.
Thank you, Mr. Plattner, for those encouraging remarks, and really also for the importance that Switzerland assigns to missile non-proliferation and specific topics like additive manufacturing in particular. So now let us move over to our panel. So I would ask the other panelists to now turn on their video and join me. Okay, I can see all of you now. Perfect. So as we move over to the subject matter of this webinar today, in the title we asked somewhat provocatively 3D printing missiles on demand, and then we went on to say, well, challenges for the missile technology control regime. And we will try to dissect this question as we move through the discussion today. And as indicated, the focus of the discussion will be on the challenges for the MTCR, but we will also be looking at some of the measures that are more at national level towards industry and other stakeholders, because that is what the environment and export controls is. It's not just one place, and the MTCR has a certain role, and talking about that role is important, but it also goes beyond that. Let me very briefly introduce some of the sort of like background topics, because I think we have an audience with various backgrounds, and I assume different levels of experience with additive manufacturing and the MTCR. So just as a brief reminder, the MTCR, that's the Missile Technology Control Regime. It's the multilateral export control regime concerned with missiles and other uncrewed delivery systems capable of delivering weapons of mass destruction. It's an informal group of 35 states that engage through various MTCR bodies to harmonize the export controls and maintain control lists of items that should be subject to export control. It had other roles, but this is sort of the core of what it does. On additive manufacturing, additive manufacturing is a category of production techniques where materials are usually deposited and fused together layer by layer to produce an object. And this is very much in contrast to traditional subtractive manufacturing, where material was usually removed from a larger block, whether that be through machine tools such as lathes or milling machines, but it was usually taking away material from a larger object. A simple analogy that is often being used here is that of a potter who combines lumps of clay in a really successive process to form an object, as opposed to a sculptor who chips away bits of material from a larger block, for example, of marble to get you a sculpture. Now, modern additive manufacturing techniques have often been described as 3D printing, particularly because of their similarity to the process of a common desktop inkjet printer that everyone knows. There you have precisely sprays a layer of ink on a piece of paper, but instead here we have various techniques that are used to build up layer upon layer upon layer, and this is really many, many, many layers of material to then form a three-dimensional object. And that object, because it is built in that way, can be of almost any shape and geometry. The techniques and sophistication, but also the materials that can be used, they vary considerably. So you have your common desktop 3D printer that melts a thermoplastic in a thread through a hot nozzle and deposits that layer upon layer. I think everyone knows these and has seen videos or has seen them in person, but this goes up to really multi-million-dollar machines that produce metal objects by scanning layers of extremely fine metallic powders with a laser or an electron beam repeatedly in order to then form an object made from that. One maybe important thing to remember is also this is a highly automated process. The instruction, the operational parameters for a 3D printer to then do the print job, they're all digital and they can therefore be easily transferred. But there's also a lot of other steps and a lot of know-how that goes into it. So one might be saving on know-how about some other manufacturing techniques, but additive manufacturing is also actually quite hard when it goes towards the higher end of it. And there's still, quite a number of challenges related to producing items with specific performance characteristics in terms of getting the certification for the items and so on. Now, how is additive manufacturing relevant to missiles and other delivery systems? We've just recently published a new report on this, as has been mentioned, and I'll just drop the link in the chat again for those who might have not seen it already. And one of the things that we found is that additive manufacturing is increasingly being used to develop and produce a growing range of components for missiles and uncrewed aerial vehicles, both by civilian and by military companies in the aerospace sector. A lot of items which can now increasingly being produced with additive manufacturing. This includes rocket propulsion system components, such as combustion chambers, turbopumps, nozzles, but there's also interesting developments in printing of energetic materials, which could be used for the actual solid propellants of a missile. So we see a lot of developments in this area. And with that have come more and more concerns about the proliferation risks. Export controls already cover a lot of different aspects of additive manufacturing, machines, materials, software, technology, but all just to some extent. And a lot of the coverage comes from overlaps or because of the possible end use. So there's been a lot of thinking about what needs to be done in the area of export control to address this. And I will leave it at that. I think this provides, hopefully, for everyone a bit of background where we stand with this topic and why it's relevant for the MTCR. And with that, I would now like to actually turn over to our first speaker, which is Andrew Horton. As Mr. Plattner mentioned, Andrew is a senior technical policy advisor to the UK government and the head of the UK's technical delegations to both the MTCR, but also to the Nuclear Suppliers Group. And since 2019, Andrew is also the chair of the technical experts meeting of the MTCR, which is the technical body that the MTCR assembles to discuss technical developments in the area of missiles. So I think he's the perfect person to tell us more about the role of the MTCR in addressing proliferation issues posed by additive manufacturing. And I'd like to note that Andrew is speaking today in his personal capacity, so his remarks should not be understood as presenting positions of the UK government or of the MTCR. So Andrew, why is the MTCR concerned with additive manufacturing, and what is the role that the MTCR plays in addressing proliferation risks posed by additive manufacturing?
Well, thank you very much for that question. Before I start, I'd just like to say it's a real pleasure to be able to talk to you this afternoon and to thank both SIPRI and the Swiss government, particularly the kind words from Nicholas. It's an interesting question about this sort of technology and the potential risks that can be sort of pointed to with additive manufacturing. And the MTCR, along with our sort of close cousins in the Wassenaar arrangement, have looked at additive manufacturing in quite some depth. There are some interesting opportunities, risks, or whatever way you'd like to put them, with this dual use technology. And it's the nature of dual use technology that there are sort of benefits to this technology, but there are also risks around the misuse of that technology. And I think the key thing and the key work that we've been doing within the technical experts meeting, the TEM, which is the sort of lead group within the MTCR that discusses a range of technical issues and maintains the technical annex that provides the list of controlled items, is what are we actually seeing in terms of specific risk, how we then introduce a suitable control that sort of balances the sort of benefits and the availability of this technology with the need for control, and also to take into account the ability for exporters, licensing authorities to make effective licensing controls around this, and to sort of get licenses for their legitimate exports. So it's quite a complicated, complex issue, not helped by the fact that the technology is relatively immature, and that there are sort of lacking sort of recognized international standards that's always provide the sort of technical backbone for many of the controls that we have on technology such as this. So it's quite a sort of challenge for both the MTCR and the Wassenaar arrangement technical colleagues. But I'm sure as things develop, as the technology matures, then there will become sort of a greater opportunity to control that technology, particularly that technology that presents the sort of highest levels of risk. So I hope that sort of sets a bit of a broad picture for what the MTCR technical experts meeting does and has been looking at in this type of in this area. Thank you very much.
Maybe I can sort of like drill down a little bit further on that. I think for the audience, it would be interesting also to hear a bit about how this usually works in the MTCR when topics are brought in. Who does the assessment? To what extent actually the MTCR is a helpful forum, because it brings together these technical experts from 35 countries who are to the largest extent suppliers of missiles, but also of the relevant technologies around it. I think, you know, maybe give us a bit more background on, how that process works, how the MTCR sees its role here?
Yeah, oh, absolutely. Yes, okay. I mean, any decision that's made by any of the technical regimes, the multilateral export control regimes, is consensus based. So everyone has to agree around the table to implementing controls and the control text. The role of the technical experts groups or meetings is to take a proposal from a participating state and then discuss that, develop the suitable text and agreed text, be it sort of looking at the technical parameters, the associated values with those parameters, and so forth. So the advantage of a multilateral approach, such as the MTCR, is that we can bring experts from the various countries that are technology holders. So not all countries that are part of the regime have to sort of hold that technology. So some countries will have a far better understanding of additive manufacturing. Others will have a far better understanding of the implications in terms of the types of components that can be manufactured using that technique. Other countries will bring expertise in things like materials, and very much part of the discussion has been around feedstock materials that go into these machines for producing components. So the advantage of, as I say, the multilateral part is to bring the sort of expertise and knowledge from the widest pool as possible of those countries that are key technology holders in this area. So I hope that sort of brings a bit of a detail on the working of the group.
Thanks, Andrew, and thanks for outlining a bit how the MTCR and in particular the TEM was about seeking to address some of the issues that are there. And I mean, I hear you on the relative immaturity of the technology, though in our study, I think we saw that there is actually quite a lot. The point is, where are they in the stages of development? How far are they on getting the certification that is required? And particularly in the civilian space rocket area, there's more and more that we see. NASA programs are jumping at us from everywhere on this topic. So it's fascinating to see how this develops. And something that I've looked at, but that I've learned a lot about from Robert is the aspect of who is actually involved when we talk about additive manufacturing. Who is the stakeholders that we're concerned about in export control? Who actually needs to apply it? Who's concerned by it? Who needs to be reached out to? Who has the awareness of the issues? Who knows much about the technology? So with that prompt, maybe let me turn to Robert, our second speaker, who will talk about the stakeholders that we have to think about in this area of additive manufacturing, and where there might need to be awareness raising, who are concerned with export controls. So just quickly, so Robert is program director for export control and for the export control and non-proliferation program at the James Martin Center for Non-Proliferation Studies at the Middlebury Institute of International Studies, and he's an adjunct professor for the Middlebury Institute. He's written extensively on the topic of proliferation risks and stakeholders in the context of additive manufacturing. And so, Robert, what can you tell us about this ecosystem of stakeholders that's involved with additive manufacturing, and why this actually poses concerns for export controls?
Thank you, Kolya, and also for the opportunity to contribute to the discussion here, and congratulations again on your publication. Our work at the Center for Non-Proliferation Studies, CNS, on this topic really got underway in 2017, and certainly we looked at the technology and its dual uses surrounding additive manufacturing. But what was striking to us also was the sheer variety of entities that were involved in that ecosystem that surrounds additive manufacturing. And this includes industrial players, and not just the makers of the printers themselves, or the sort of direct users of those printers, although that's certainly a major component of this ecosystem. But there's also materials suppliers, there's software providers, there are technical services consultancies that are all about sort of integrating these features of the additive manufacturing supply chain, inclusive of those materials, inclusive of the printers, inclusive of the software that brings it together. Additionally, many of these players are collaborating with universities, academic institutions, who themselves are embracing additive manufacturing as a sort of a novel and emerging area of engineering, one that holds great promise and is also attractive to students and future engineers that are engaging in academic programs related to engineering, related to manufacturing, and so forth. Beyond this arena, the industrial arena, the academic arena, another notable feature, although certainly maybe not involving the highest end equipment, is the fact that this technology is also diffuse across the consumer and retail realm, to where you have individual hobbyists that are experimenting with the technology basically for fun or personal interest. And some of these groups, though, have come together into maker spaces where they're pooling their resources and purchasing some higher end equipment and sort of cooperating in the use of that equipment for just experimenting, seeing sort of what they can make. Largely very positive dimension of this, but also kind of, from a security sense, kind of dramatically illustrated some of the challenges when you have a nonprofit group like Defense Distributed, focusing their activities, on the production of handguns. So it is a very diverse ecosystem spreading across multiple sectors. Additionally, this is infused with an entrepreneurial energy associated with the fourth industrial revolution. There's a lot of interest and promise, surrounding the possibilities that additive manufacturing may bring to the global supply chain and to sort of to whether it's in industrial level goods or consumer level goods, and what that promise may bring. That energy is connecting and relevant for the MTCR focus here today with entrepreneurial energy surrounding other areas, most notably space and space launch vehicles, dramatically illustrated by startups such as SpaceX, which we know is using 3D printing in the production of their vehicles. And so this energy in turn is also attracting investors, venture capital, and so forth, which represents another part of the ecosphere, sort of the funds and so forth that are entering this space. So it is the variety of players that are working in and focused on the additive manufacturing domain, really cannot be underestimated. And this does raise challenges with regards to export control outreach, especially if we compare this, if we, let's say, go back to the days of where the latest advances in this space were still in the subtractive manufacturing realm. And so, this is the activity, the emerging technology is not confined to, let's say, a limited number of government labs, a limited number of large multinational companies. Rather, you have the full range of private sector actors that are engaged in the process. Moreover, they're globally distributed, another feature as well. So the challenge is there. It holds great promise, I think, for the related to the benefits of additive manufacturing, and maybe one way to look at it to increase awareness of proliferation and the dual uses of these technologies. But certainly, there are challenges, toward that end.
Thank you, Robert. I think this was a really great outline of, what really entails this ecosystem of actors and stakeholders that are concerned with additive manufacturing. And one of the points that is often talked about in this context, particularly as we still see many of the difficulties that Andrew mentioned when it comes to getting to controls that would define items, is the importance of the know-how and of the technology that is being spread. And to that extent, we have controls that are based on the end use that already apply, but there's also a huge importance of actually raising the awareness about what are possible concerns and where there might need to be vigilance also from the side of different stakeholders in this area. We asked the question, printing 3D printing missiles on demand. There's also many service providers who basically provide you with the printing service, and the technical sophistication of that is growing as well. So this is really an interesting aspect of this, and this really brings me over to our next panelist, Dr. Andrea Visky, because she will talk about the challenges and sort of maybe ways forward about how we can improve this outreach, engagement, and awareness raising with industry, particularly in cases of emerging technology sectors. As a quick introduction, Andrea is the director of the Strategic Trade Research Institute and the editor-in-chief of the Strategic Trade Review, a journal specialized in export control, strategic trade control. And I think particularly for the students, but also everyone else in the audience, it's an excellent source to find scholarship on many strategic trade control topics, and we're very happy that someone stepped to fill that space. Andrea is also an adjunct professor at the Shah School of Policy and Government at George Mason University and a non-resident fellow at the Stimson Center. Earlier this year, Andrea was one of the authors of a report towards Outreach 2.0, Emerging Technologies and Effective Outreach Practices. And as I said, I think this fits really well with where Robert left us off with. So no further ado, hand it over to you, Andrea.
Well, thank you, Kolya. Thanks for inviting me to speak today, and congratulations on your published paper, which I thankfully had the time to read before this event. And thanks as well to Andrew and Robert for their remarks. I hope to build a little bit upon that from the outreach point of view. So I've been asked to talk about the issue of how to strengthen outreach to industry and other stakeholders in emerging technology sectors. And this question is really quite challenging due to a number of factors. And I'm first going to talk about some of those challenges and then the way that our research and the subsequent report sought to address them. So the first challenge is that emerging technologies, and specifically additive manufacturing, of course, this is an area where it's a rapidly evolving field. And as Robert pointed out, there's a very diverse set of stakeholders. Some of them represent large multinational companies, but also smaller companies, startup companies, do-it-yourself communities, as well as collaborations between the private sector and academia, and then, of course, the interest in from academia and research organizations. And while export control outreach has made significant strides in developing practices and gaining experience in reaching out to those traditional exporters, there's less experience and less of a strategy in terms of reaching out to these more non-traditional and new stakeholders. The second challenge is that national governments on their own and collectively, for example, in MTCR, cannot as of yet regulate a lot of these sectors through the use of national control lists and other traditional means. And so they have to a certain extent, but because of the way that the technology is evolving and how rapidly it is evolving, as Kolya points out in his paper, previous proposals on additive manufacturing have at times not gone through in the regimes because they can be quickly rendered obsolete or cause more harm than good to competitiveness and to other things. And so basically alternatives have to be found to control-list-driven outreach efforts in the emerging technology realm. And so these are focusing on other ways to raise awareness or to increase compliance with catch-all or kind of self-control in different ways. And finally, the third challenge is that the traditional relationship between non-proliferation and trade is evolving on a practical and a conceptual level. So export controls continue to play a role in non-proliferation, but technology in particular is immune to borders. And the intersection between intangible transfers and advancing technologies poses a particularly stark challenge for traditional list-based controls and necessitates creative thinking regarding how to target and conduct outreach. And moreover, as stakeholders, so those potential exporters of technology become more diverse, technology acquisition pathways adapt, meaning that technology is acquired not just through import, but also by acquisition from foreign direct investment, for example. And so outreach has to really take into account and think broadly, not just about the traditional exporters, but that those technology holders themselves can be acquired and that technology can spread in that way as well. So with that, I'll just move on to the outreach model itself, which we developed through research and government surveys with different officials and looking at what kind of practices were already out there. And basically, we came up with this model that we find needs to be an outreach model that is more customized, targeted, creative, real-time, and collaborative between regulators and exporters. And I'll quickly go through the 6 characteristics. The first is to have specific targets where government authorities assess private sector or other stakeholders according to risk and threat and organize outreach resources accordingly. So it's almost akin to building a kind of risk and targeting profile through which to use outreach resources most effectively. A calibrated approach, so where government authorities adapt outreach strategies and communication differently to different private sector groups. Third, flexibility and preparedness. So using outreach methods, messages, and tools that can change and adapt rapidly to evolving circumstances and to the changing landscape of exporters. And number 4, the use of a variety of tools. So written tools, electronic tools, reaching out through webinars, but also this leads me to number 5, inclusivity and actually collaborative approaches where exporters are actually brought into policy decisions or committees are formed that are collaborative between regulators and exporters in order to develop a relationship and a sense of trust, and also to help government regulators keep abreast where the technology is going. And then finally, collaboration and co-development. So working with exporters on the actual creation of outreach messaging tools and activities in order to best understand what they actually need and what's most effective. So yes, thank you very much for, again, for having me here. And I look forward to the rest of the discussion.
Thanks so much, Andrea. And I think you made a number of really important points that go towards many of the challenges that those of us who are involved in capacity building, who are doing some of the outreach work, have encountered, and much of what is also being fed back by industry commonly. I'm to some extent left with the question, to what extent does one have to carry this to the concerned parties in this ecosystem that Robert described, and to what extent is there awareness? So, for example, participating in some industry events, I think the larger players, defense companies who are using additive manufacturing increasingly to develop products, like, they are aware of the outreach, but the different layers that Robert described, I think one of the important things that come out of what you say is that there needs to be a focused effort to identify and then get into this collaborative mode. I think actually I want to turn this over now again to Andrew, because to some extent what we've talked about now is something that is, I guess, mostly implemented through the national level, but it's something that, I would think the MTCR also concerns itself in terms of the discussions that are being had, and maybe you have some thoughts to build on this in terms of how does the MTCR complement this in its role, what can be done in terms of sharing experiences, for example.
Thank you, and just want to say thank you to Robert and Andrea for a great presentation. It's certainly given me some things to think about on what they've said. I think when it comes to the role for the MTCR, the role of the MTCR as one of the multilateral export control regimes is to sort of implement a sort of supply-based approach to non-proliferation, and that's its role. It does provide sort of information exchange on best practices and issues of concerns within the sort of group, and undertakes outreach to non-members of the regime. So that's a very important aspect for that. But I think the problem, particularly with missile proliferation, is that there's no overarching treaty or other framework compared to, for example, the nuclear sector or the chemical or biological sectors, where you have an international treaty in effect that provides far more ability to have controls other than supply-based export control. And so again, that's a sort of wider piece for discussion. But I think what Robert said, and Andrew has also said, about the sort of almost a perfect storm of this technology being adopted by new non-traditional players in the space sector, and the space launch sector in particular, is almost a sort of perfect storm event, because they're the ones that aren't the sort of usual suspects when it comes to awareness of export controls. So the traditional aerospace and defense companies know export controls like the back of their hand, because they have to deal with a day-to-day basis. New emerging companies, particularly those that sort of come from a sort of almost entrepreneurial, risk-based culture, sort of see export controls and awareness of non-proliferation as being a sort of handicap and almost rules to be not ignored or broken, but put to one side. So again, the issue around sort of cultural aspects of this is also, I think, pretty key, and I think it's probably the biggest single proliferation risk with this technology, is this sort of social, cultural aspect, less so the technology. And the reason for that is much of the technology for production of controlled rocket missile components is controlled by virtue of being for the development and production of those components. There's that awareness piece when it comes to this new technology approaches, new space 0.20, whatever they sort of call it. That is probably the single greatest proliferation challenge. And I'm not sure, given the sort of change away from purely physical exports to now a universalization of the technology, that the MTCR is probably out of its depth to a certain extent. It still has a place, absolutely certainly has a place when it comes to controlling things like the export of the feedstock materials and stuff like that potentially. But as I say, the technology is far more difficult to control from a purely supply-based control approach. So I hope that sort of addresses and answers the question.
Yes, thanks. And I mean, I think this brings us back to actually both Andrea and Robert, because this poses the question that, you know, if we consider this set of stakeholders and this growth in and entrepreneurial spirit, the characteristics of this sector that we have, for example, in the micro launcher space and other areas, you know, how do the challenges that we have there, how can they be addressed? And actually, you know, Robert mentioned this technology is spread quite internationally. There's certain concentrations in some of the high-end sectors, but it's international. So are there then differences in terms of how states are experiencing challenges in doing their outreach efforts, in reaching out to national industries that are concerned with this? Maybe you can start us off on that, Andrea.
Sure. So in terms of differences in how countries are meeting this challenge, you know, there's a number of challenges just to begin with. So the first is keeping track of the technology and who the players are on the landscape. And then also there's the component of linking advances in technology to tangible WMD or advanced conventional weapon risks. And those are all kind of dependent in terms of identifying the risks within a country to how well the interagency and information sharing and coordination works between government agencies as well. And so there's going to be differences between countries in addressing them because of the importance that they put on it, because of their previous experience with outreach, because of the amount of resources that they have to address these challenges, access to information that can help build a non-proliferation strategy that takes this challenge into account. And then also we have, you know, of course, the possibility of countries that will be holding this kind of technology that are not members of supply regimes now and in the future, and sort of their ability to characterize threats and counteract them and to take them seriously and conduct outreach in this area.
Maybe then if we zoom in a bit to the ecosystem again, Robert, because many of the concerns when we interact with industry is often the discussion is around reducing costs, enabling new specific technical capabilities, getting the certification right, getting the right techniques for non-destructive testing. It's very focused on that. And then the other side is the military end users who are asking of the providers, okay, so where are you at? What can we use? How far along are we? And how can this be integrated? And the answer to some extent of that has been rather at the, I guess, lower end of the technology to some extent in terms of what we see being deployed. but the conversation that is happening within industry often doesn't seem as focused on non-proliferation risks, on export control. You know, like in these types of circles, we often discuss those issues, but I'm not sure whether they're really there at the level within this ecosystem. And I was wondering if you have any, you know, ideas or views on, you know, what might be something that could be done to improve that also on that level, and you know, in a more targeted way that picks up how that ecosystem is structured.
Yeah, thank you. And it is, you know, what you described as, let's say, the sort of immediate focus areas for, you know, those especially industry stakeholders that are in the AM space, you know, being focused on the, you know, on you know, the sort of current, let's call it leading edge, cutting edge of technical development and achieving certain capabilities. You know, this is, you know, arguably an indication of success in integrating additive manufacturing, you know, into you know, key sectors such as aerospace, the supply chain, and so forth. So it's kind of natural. I think you're going to see this focus on, to some extent, just solving the core technical problems. And yes, it can it presents a challenge in terms of potentially sort of diverting or attention to, say, you know, the security and responsible use domain, and then, you know, amplified all the more by the, you know, sort of entrepreneurial energy that I described earlier, and that Andrew had noted as well, particularly in the you know, in the space launch sort of vehicle arena. And sort of thinking about this, when we look at the ecosystem, it can kind of look almost, you know, chaotic, if not anarchic as well. But I think specific to, let's say, the space sector, government is still a player. If we look at SpaceX, if we look at Blue Origin, they are competing for government contracts. There is an effort to sort of seek government and potentially military end users as customers. And I think within that may offer some structure within at least a limited subset, but a significant one within that ecosystem. In that, if you have a government or military user that is a customer, and then you have below that industry, perhaps collaborating with universities as the quote unquote supplier of a solution or technology, part of the RFP process, part of the contracting process, there may be, will typically include export control language, but a lot of that is pro forma. It's like paragraph 33 out of 50, and it's just sort of nominal language that states, you know, well, you know, the the grant recipient will follow, you know, all applicable laws and regulations in export control. I think there could be an opportunity to really define sort of the proliferation risk associated with the AM, and perhaps create some, let's say, an attestation or a very specific letter of assurance that identifies those risks, confirms understanding of those risks, and then maybe may actually describe due diligence steps taken to mitigate those risks. And if that's sort of embedded within the contractual process, there is an incentive to taking a look at that, meeting those requirements. And I think we're seeing the same thing with cybersecurity, where, you know, more and more you're seeing cybersecurity criteria and provisions appearing in the government RFP process. So this is a very niche area, but it's something that is relevant to the space launch vehicle arena, and maybe relevant to sort of aerospace programs more broadly. So it could be sort of a kind of a, you know, no pun intended, a launching point for some concrete sort of work in increasing awareness and attention to the risk.
Can I just jump in and ask a follow-up question to Robert? Just in your research in terms of the landscape, have you seen companies like that actually adopt and publish their own due diligence standards already, even without having to do it because of a government contract, or also applying that kind of standard to, say, smaller organizations or academic or research organizations that they work with?
It's going to be a mixed answer, Andrea, on this. I'm not sure that we're seeing, let's say, something emerging here specific to additive manufacturing, but something that we have observed just looking at the at compliance, export control compliance trends and developments in industry, is that there has been an effort, I think, towards sort of innovation and tailoring due diligence strategies in this space, or in, just broadly speaking, the industrial space. And with the introduction of catch-all controls in the 1990s and 2000s, this was followed, in maybe a few short years afterwards, you begin to see in industry the use of specific letter of assurance mechanisms and so forth. And while many of these may have been sort of based on sort of regulatory authority guidance or recommendations, over time these really did develop into sort of tailored, tailored approaches specific to the company's needs and risk assessment. So I think there's a potential there. We've already seen it on a broad industrial level, just beyond additive manufacturing and kind of going back to the introduction of catch-all controls. But specific to AM, we aren't seeing, I haven't seen anything say specifically, but it's not to say it doesn't exist. It might be happening out there.
If I may just come in with what Robert has said about the space launch industry, and I certainly work very closely with my colleagues from the UK Space Agency and the Civil Aviation Authority, who are the UK space launch regulator. And as part of any licensing for operation, there is an element of non-proliferation that has to be built in to their operation. So I think this is sort of really sort of key point about the sort of almost a sort of multi-agency, cross-government, cross-industry. It's not approach. It's not just about the more traditional export controls. It goes further, particularly because of the risks around the transfer of know-how and knowledge rather than physical items themselves.
Thanks, everyone. I think this is developing to be a really nice interactive discussion, and this is really exciting. To our attendees, get your questions in. We'll be moving into the Q&A part momentarily. I think there's a few short ones there already, but I'll probably pose the last question to Andrew, because you mentioned the Wassenaar arrangement at the beginning, and I think there might also be some colleagues in the audience. The MTCR is obviously not the only export control regime that is concerned with the additive manufacturing topic. I would actually argue that all of them are, but particularly if we're talking about missiles and this area, but also more generally, if we're talking about machine tools, it's often been the MTCR where many of these discussions were. And some have said, isn't there maybe an issue here where we have multiple regimes talking about the same topic and thinking about ways of controlling it? And there has been some dialogue between the two regimes. This has been limited and it's always been difficult. I understand, because there's different memberships, but maybe you could tell us a bit more about engagement between the regimes, to what extent that can be a tool also basically to prevent that we have controls that are overlapping in a way that would not be beneficial.
Yeah, I mean, certainly the technical experts from the regimes do talk with their sort of fellow technical experts at the national level, obviously. But at the sort of more inter-regime level, there has been informal meetings, discussions, workshops around key mutual technologies, including additive manufacturing. I think it's sort of important to understand that the regimes look at different aspects of proliferation. And in the case of the Wassenaar arrangement, it's not technically a non-proliferation regime. Its sort of rationale and reason for existing is to prevent the destabilizing accumulation of conventional weapons. So its focus is more on the conventional weapons issues and the potential for sort of build-up of arms in regions, sort of regional conflicts, civil wars, and that sort of thing. So they have a slightly different worldview, as it were. But the sort of missile technologies that the MTCR is concerned with are the same for the Wassenaar arrangement because they're military missiles predominantly. So the technology that can be applied for the production of an MTCR, missile of concern, space launch vehicle, sounding rocket, etc., applies equally to the systems that are of concern to the Wassenaar arrangement. In terms of, you mentioned machine tools, conventional subtractive machine tools, the MTCR doesn't actually control conventional subtractive machine tools. The Nuclear Suppliers Group and the Wassenaar arrangement both control machine tools. And there is a divergence in terms of the sort of technical elements of the respective controls, even though we have been working very hard in the NSG to bring ourselves aligned with the Wassenaar arrangement in terms of the sort of technical parameter that they look at in terms of sort of controlling the machines of interest on that. It's a difficult one, and it illustrates the challenge of working across regimes because of a different focus and, as I say, different members of those regimes. So I hope that sort of answers the sort of question on that.
Yes, thank you. And maybe to just jump straight into the Q&A now. Tracy Wilson picked up on the topic of additive manufacturing as a service, and also draws the parallel to what we see in the DNA synthesis field. So we actually do see that these service providers have more and more higher end capabilities that they offer to their customers. And Tracy is asking, how does or will the MTCR address these distributed manufacturers, suppliers, for example, via a know your customer approach? I think, Robert, you looked at this quite a bit in one of the studies that you did in terms of the service providers. So maybe you can give some brief comments on that. And I think, Andrea, your question to Robert before was also going a bit into the direction of the example that we know from the DNA synthesis provider era, because there you saw that those providers actually stepped up and did more self-governance before there was regulation as well. And that's often an example that is being brought up here. So maybe after all, but you also have a few comments on that.
Yeah, thank you. And just an excellent question, because additive manufacturing services is certainly a feature of the ecosystem you just described earlier, and a significant one. And we have sort of looked into sort of that arena of the additive manufacturing supply chain, and there are notable players that are offering sort of high-end additive manufacturing services, and with a particular focus on the aerospace sector. One of those, at least certainly active, in the time of our research, in the 2017 to 2019 timeframe, was a company, Stratasys, which, interestingly, in terms of their sort of public-facing view, their website sort of highlighted their knowledge of export compliance laws and regulations, and sort of the sort of intent there is that, as let's say you have a new customer that's being onboarded, is maybe working in a space related to aerospace or defense, that Stratasys could assist in that arena and offer know-how. And so I think know-how in a good sense of compliance. So so I think there's some promise there, and arguably sort of EOS, I know in Germany, is offering printing services as well as finished equipment. So these sort of larger players may have the benefit of setting the tone for the service providing space, sort of an example of best practices and so forth. So we came away somewhat optimistic about that. And the details of the due diligence approach and so forth that may be used by the service providers, we don't have as much of a window into, but I think there's some promise there, just given what we've seen with the key players, particularly in aerospace.
Andrea, do you want to jump in and maybe also, on the aspect of, for example, know your customer approach as one of the things that is often being described as a good practice in this area?
I mean, sure. I don't actually have that much more to add to Robert's comments, except that I find this discussion really interesting because of the potential of a more bottom up approach in terms of the private sector and other stakeholders kind of developing their own organic due diligence in this area, and that could be that holds promise and can be more effective than the top-down approach, or can have like a very good interplay with it. So I just think that it's really, really interesting and holds a lot of promise in terms of possibly developing standards that come from industry itself. And we've seen it in a couple of other sectors as well.
Did you want to jump in, Andrew?
Yes, a couple of things have sort of struck me about the question and the answer to the question. I mean, from an MTCR perspective, we already have controls on what's termed technical assistance. So within the definition of technology within the regime, we have technical data, which is the sort of information we're sort of relatively all familiar with, but we also have technical assistance as an element of that, and that's providing a service or consultancy, training, and so forth. So potentially in this instance, an MTCR context, those activities would constitute technical assistance, and therefore would be subject to licensing approval. In addition, we have catch-all provisions, as you mentioned. So even though if something's not subject to normal export control, it could be subject to control based on the end user or the potential end use that it's going to. In addition, I'd also sort of point out other mechanisms within non-proliferation, and particularly proliferation finance controls. So in terms of know your customer, if you're providing a service that involves remuneration, then you shouldn't be doing that with someone subject to a sanction, so a sanctioned entity. So you should have a due diligence and sort of internal compliance procedure as part of your normal business if you are potentially dealing with entities subject to sanctions and these proliferation finance controls. So I think there are a range of mechanisms that companies should already be doing that would help in sort of instance of service provision.
Thanks, Andrew. Looking at the Q&A, so I think one of the questions was more or less already answered. There are a lot of components that are increasingly being developed using 3D printing, additive manufacturing, that is particularly those that have internal voids that need cooling channels, just because there the technology provides a lot of advantages, and that is where we're seeing much of the development that is currently ongoing and also already testing by those developing space launch vehicles. There was another question by Jesus Tabares, who is asking about if the cost reduction in missile technology that is among others, enabled by additive manufacturing, to what extent that could also be an issue. And he mentions the Latin American context and the non-state actor context. Andrew, maybe you want to sort of like, maybe bust some myth here, or just sort of like set this in perspective a little from the technical side.
Yes, and we talk about additive manufacture, 3D printing as sort of a process for producing a finished component. It's very much not like that. Between 50 to 75% of the overall time for production of a component that's been subject to additive manufacturing involves more traditional subtractive manufacturing techniques. So you have to remove the supporting structure that's used when you sort of produce these items. Gravity will tend to sort of distort and pull down. You also have structures to control the thermal cooling of the components. In addition, you usually have to subject the item to isostatic pressing. So you put it into a very sort of chamber and subject to very high pressures, just to reduce the number of voids that sort of appear in the material that have affected the strength of the component. So there's been a lot of hype from industry, typical sort of industry hype with new technology. It's the sort of bee's knees, the be all and end all of manufacturing. It's not. It produces what we what we refer to as a near net shape. So in effect, it's a sort of substitute or sort of for a typical casting process where you're producing something pretty close to what you want, and then you have to do the sort of additional processes. So in terms of cost reduction, it's questionable whether there is much of a cost reduction. What it does do, and this is particularly why it's used in the sort of space launch sector, it takes away a certain amount of skill on the part of the sort of engineers and technicians and craftspeople that produce these components, and sort of almost automate the process and leave it to the machine to do that, rather than the sort of skilled tradesman that was typically used. So for example, in the production of a rocket engine, you have cooling channels, and that usually involves sort of shaping very fine copper tubing or nickel, typically nickel tubing, and it's a very, very skilled process. So in fact, as I say, additive manufacturing de-skills the process, to be honest, but it doesn't really impact on cost significantly. There are additional steps that add to the cost.
Thank you for those clarifications and putting some of that in perspective. I mean, certainly, one of the takeaways also for me after looking at this for a number of years now has been that it's not really a revolution of manufacturing technology, but it's something that is very specific, has very specific applications, as long as we talk about those high-end applications. And as Andrew was saying, there's many other components and steps that are involved. I sometimes worry a bit more about those applications that are at, I guess, the lower level of the technical end, though for at least the missile space, they are probably less relevant. There's other concerns, and there's more and more that we see the use of 3D printing, additive manufacturing in other military contexts and for more low-tech solutions. I think there we'll certainly have to watch how things develop. Conscious of the time, I know we particularly see a very interesting question on the cybersecurity aspect of this in the chat, and I think this is something that goes across actually many of what we talk about as emerging technologies, and it's both an export control concern, but it's also a wider security concern in this area. So this is a really, really important and interesting aspect where I think also from our side more work needs to be done, how those interlink. But I think I would like to draw it to a close. Thanks so much for everyone who posed questions in the chat. If you want to, please feel free to also follow up with us. I think everyone has at least my emails through the event, so please feel free to reach out if you would like to continue this conversation, or if you have specific other questions. And I mean, if the speakers agree, I can also try to put you in touch with them if there are specific issues that you would like to follow up. And you know, to all the participants that have joined us, for the audience, please join me in thanking all of our panelists and our introductory speakers for their time today and for their really excellent remarks. I certainly always learn a lot when speaking to each of you, and I hope our audience enjoyed the discussion as well.